Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our modern C++ series. In this lesson, we're going to continue talking about the standard template library, but we're going to continue our discussion on iterators. So if you haven't seen the previous videos on iterators, make sure you check the playlist so that you watch those first. Because today we're going to be putting things all together and writing our own iterator from scratch for our own custom data structure. So with that said, let's go ahead and dive into this and go ahead and look at iterators, recapping a little bit of what we talked about, and then ultimately writing our own iterator in this video. Now, there will be some other follow-on videos on this topic. I think we're probably going to end up doing a little code review just so we can kind of summarize things for those who don't want to write it from scratch. And then I need to talk about some other things like iterator and validation, some of these other important topics. So make sure you subscribe so you don't miss those. And with that said, let's go ahead and dive into it, starting from our favorite website, Cpp Reference. And again, we've been talking about iterators and this idea that they are a generalization of pointers. So let's go ahead and just get a high-level overview of, again, what iterators are, some of the things we've talked about, and then we'll start implementing things. So again, the idea is an iterator is an object that we are creating. So let's say we have some container data structure. Maybe it's a vector, maybe it's an array of some type here, and we've got some collection that looks like this. And one way that we can access elements is, well, if I know the actual structure of this particular container, that is that it's a sequence of contiguous elements, I could just index into it. But again, what if I have some sort of data structure here, like a tree? Is it directional? Is it bidirectional? We don't really know, and sometimes we don't want to have to care, but we do want to be able to visit all of these elements here in maybe some particular traversal or some order here. Okay, so for those of you who've taken your computer science classes, you know there's many different traversals of our tree-like or graph-like data structures, just as an example. But that still yet applies for our contiguous containers or other just linked containers as such here. And the really neat thing about iterators is if we have them and implement them, well, we basically get access to the rest of the standard template library. Things like, if you allow me to just go back to Cpp reference here, the algorithm library, for instance, we'll be able to use iterators, or we're going to be talking about some things like ranges where they can be really useful. Or even if we go just to the iterators library and some of the things that we talked about here, if I scroll way down here towards the bottom, some of the different operations, depending on what types of iterators that we implement, we can have things like advance, distance, next, some of these other functions that might be useful to us. Okay, so that's the basic idea, and we want to be able to construct or generalize this idea of how we access elements in some sort of object here. So this is our iter object. Okay, so let's just pull up the definition of iterator one more time, and then we'll go ahead and dive into this by first looking at an example. So again, it's a generalization of a pointer. Now, let me also, because this is a point that I want to talk about here, emphasize that just because it's a generalization of a pointer does not mean that our iterator actually is a pointer. It might literally just be an index into some contiguous data structure like this. Again, the point is that that idea is abstracted away from us. Oftentimes, again, in a graph-based data structure, it might be a pointer, but it doesn't have to be. Okay, so that's the idea of iterators. Now, let's go ahead and take a look at some iterators here. So very briefly in this example that I have here is I have a data structure here, standard vector, and it's a vector of integers. Now, I am going to use some of our modern C++ here using T, and basically T is just substituted, or it's a type def. Again, and with modern C++, it's a scoped definition here, meaning that it exists between these brackets, but just sort of for convenience, because you can see I'm going to change this data structure shortly. But the idea is, again, we have this type here, and I'm just calling it C for short for container, and showing you some different ways that we can iterate. Again, we've reviewed some of these different things before here. So let's get ready to just compile this. And we can see we have a C style loop here, where I'm just going to loop through the capacity of this vector, in which I've reserved 5 elements here, print them out here. And then I've got our C++ 98 style loop with an iterator here where I have begin and end, and then I can increment through all the elements, dereferencing each one to access each of the individual elements in our vector, which we know, or if you've been watching this series, that it's just a array behind the scenes, a dynamically allocated array. And then we can start getting into interesting stuff here. This is still sort of C++ 98, but the algorithms library here, for instance, I'm doing a for each, and this time I'm using begin and end. So this is where we can, again, see our iterators here, which are just being returned here. And then I'm going to call this lambda function here on each of our elements here. Okay, and then I also have range-based for loops here. Okay, which the range-based for loops are quite interesting. In fact, let me go ahead and just output this code here, because I want to just, again, show you as a reminder if you haven't been watching this series here. Let's go ahead, let's just copy a tiny piece of this here. I want to go to my maybe second favorite website as far as C++ stuff goes, to Cpp Insights, which is right here. So let's go ahead and click on that. And let's just construct, or oh, looks like we've already got one here, this range-based loop here. Okay, and this is, again, since C++ 11. But the idea is you can see that we are creating a begin and an end here. Now, for a constant character array, let's go ahead and do it with a vector, just so you can go ahead and see what we've got here. And I'll just write std vector of int. Let's just call it container, and do something like this. Let's just do auto. We'll do it by reference, each element here. And let's go ahead and, oops, yes, here. And let's just go ahead and print this out. All right, and we can see here, which is kind of interesting, that this range-based for loop, it just gets translated into a regular for loop, okay? But you can see that we have a begin and an end, and then an iterator is created here, okay? There's a little bit of, compiler stuff going on here as far as our iterators with our libraries, but it is setting up the actual vector. You can see that it's populating it with all the default parameters here that we often don't use, but ultimately you can see that we're getting begin here for whatever this range is here, and the end, okay? Which is just to show you that it's the exact same thing almost that we were doing above here when we were just explicitly specifying that. Okay, so that's pretty neat here, okay? So anyways, let me zoom in on this just a little bit here so you can read what's going on here. Again, one more time. Now, what's really neat here, though, about using iterators, and again, trying to standardize some of your code, especially if you're a library writer, if you're going to be the person who's writing some new algorithms and want to access all the C++ stuff, is, well, we can just change our type here. Okay, so now my type that I'm going to use is just going to be fixed size array. Okay, and again, if that's confusing you, just type, fixed size array here. That's all I've done here. Okay, so I don't want us to get lost in syntax when we're focusing on iterators, but that's the basic idea here. Okay, so again, that's my claim. I write some new data structure, and I should be able to use some of these new things. Let's go ahead and recompile this. And wow, okay, so now we get a whole bunch of error messages. But the error messages are informative here, okay? And what I'm going to have to show you here is what it's asking for is, well, we need these functions here. We need things like end here, okay? And that's what this message is telling us. And I'll move out of the way just so you can see here. We've got end, which is missing here. End's not declared in scope. And let's go ahead and move further. Let's see some of the things that are being used here otherwise. So begin's another one that we know we need, right? Because we had that before. And again, you could use, now I'm using this directly on my object, but I could use standard begin, for instance. That would be fine, and even preferable in some cases, as I've talked about previously. Let's see what else we're missing here. Okay, so it just really doesn't like these begins here and ends and so on. Okay, so what do we need to do to get our iterator working is the next question here. Well, we need to define the actual iterator here. Okay, so let's go ahead and do that. So we're going to just build this up slowly. And let me go ahead and introduce the actual structure here I have, which again is a fixed size array. It just allocates some memory on the heap. So it's just going to be, some simple array here. And allow me to draw it just so I bring you with me here. is fixed size array just goes to the heap and allocates a contiguous data structure like this. Okay, that's all it's doing. This is our m data, which will have some sort of type t. Okay, and I have templated this just to kind of match what we're doing in the standard template library with these different types here. And I'm also going to keep track of the capacity, okay, at line 15, just so I know the actual size of this allocation here, okay? And it'll be useful. It kind of matches what the standard template library does. So we'll have a dot capacity or a capacity member function, okay? So all I'm doing here, let's just do a little code walk, then we'll add in the iterator, is I'm allocating some memory here for my data. And I could also do this in the initializer list if I wanted, but anyways, here it is. We set up the capacity. In my destructor, I'll destroy the data. And then I have some helper functions here for accessing directly my data here and just returning it and returning the capacity. Okay, and you could imagine adding some other, helper functions if you want, but that's enough for us right now. Okay, so now how do I get to the iterator part? Well, what I need to do here is, again, just kind of following the error messages, I need some sort of end and let's go ahead and see if I scroll up here through my messages. I need begin as well. Okay, so we know we need that much here. So let's go ahead and kind of add these here. So let's go ahead and, I don't know, let's just go ahead and say begin and end. Okay, and these are going to be two of our member functions that we have. And again, they're lowercase and they're matching exactly what we see in this standard template library. Again, because that's the point. We want to be able to sort of substitute these things out. We want to be able to use range-based for loops and so on. Now, we're not quite done with these because we need to think about, well, what are they going to return? Well, what does begin and end return here? And let's go ahead and look down here. Now, I'm cheating a little bit here by using, say, auto here. But if you recall from our previous videos, and let's go ahead and just write this out, I could also write this out as, instead of writing auto, this would be standard vector int : iterator, okay, it. So I need this iterator object here, okay? That's the type here, and it's specific to a vector that works with integers, okay? That's the basic idea here. So auto is able to derive that. That's what c.begins working with. Now, a few things that are, again, just to clarify here, : remember that's the scope operator. So this is scoped within our specific instance of vector, okay? And this is a class scope, okay, versus a namespace, which is like the standard vector, okay? So that's the idea there. So let's go ahead and we want to return something like an iterator here, okay? And we'll go ahead and leave that there. And, well, let's just try to figure out what that might look like. So let me go ahead and just comment these out for now, but that's our goal, to get begin and end, because that's the iterator that we want to return. Now we could also do other fancy things where we want to return other types of iterators or define things like, maybe special versions of an advance or a distance function or something, right? If I have some graph structure to kind of figure that out. But let's just go ahead and work with these two for now. Okay, so with that said, again, the scope is within this class here. So this is where I'm actually going to create a nested class here, okay? And this is going to be my iterator here. And let's go ahead and just create this here. So it could be a class or a struct. I'm just going to make it a struct. Everything will be public here. And now I have my iterator, okay? And again, it's part of the fixed size array class here, or whatever you want to call this. Heap allocated fixed size array, whatever would be the idea here. Okay, so now what we need to do is think about some of the operations that we have for this iterator. Okay, first and foremost, we are going to need a constructor. Okay, so that's going to be the main thing that we want to actually set up here. So let's go ahead and set it up here. Iterator and, well, what am I constructing and what am I doing here? Okay, and this is where you have to make a little bit of a decision about how or what your iterator is encapsulating. Okay, so let's go back to this diagram here. And I could just have this be some sort of index here. Okay, so that's one idea here. Or I could have it be a pointer to something. Okay. Now, this is a contiguous data structure. Okay, this fixed size array. So I could just literally use an integer here and sort of keep track within this iterator object that index for the iterator. Okay, I'm going to actually just use a pointer. That's kind of nice to work with. Again, we could be more efficient. You can change this around. The point is just to show you a few different things here. So what I'm going to go ahead and do here is I'm going to define our pointer. Okay, and what's the type? Well, it's of whatever t is, which could be integers, for instance. So t star and m pointer here. Okay, so something like this. And then when I create my iterator, I need to set up the pointer. Okay, so something like this, and pointer takes in the pointer. Okay, now let's go ahead and just compile this. Let's see if we've gotten any further here. We still need begin and end here. But now I should be able to construct and return something here. Okay, now a few different things to keep in mind here. I mean, let's just talk about, again, this iterator thing that's holding a pointer. Okay, and I think we need to go to the drawing board again. And basically, again, when I drew this iterator object here, again, it truly is its own object. So I can have a bunch of iterators pointing to, different places inside of the same container. Okay, and it's the same type of data, right? It's integers in our case, in our example, but it just whatever type t is what we're looking at. But that's sort of the point here. So that's why iterator has its own internal pointer, right? I could just have as many iterators as I want, pointing to different locations here as I'm highlighting the beginning, the end, maybe some iterators advanced a few times. So that's the point here. Okay, just so we understand this. Now, there is something I'm going to do here just by convention, and this is, again, sort of the C++ 17 way to do things. It's still valid in 20, but there are some other things that we can do here. But again, I sort of showed you this, but I'm gonna just define something called using pointer equals t star here, and then just replace these with pointer. Okay. This is by convention. This is how you'll see a lot of folks write their iterators. You can kind of poke around in the standard template libraries we've been doing with some of your compilers, and you'll see that they use this using here. And again, this just makes it a little bit easier for us as we're implementing operations to just refer to our pointer here. Okay. And likewise, I'm going to do this, and this is sort of by the convention here. I'm going to do the same thing with using reference equals, and this is going to be a reference type. Okay, and there are a few other types that we need to specify here. So our value type, that's just going to be t. Okay, it's just a value. Sometimes people will just call this value as well, something like that, but value type is what I'll use here. And then we have distance, okay, which is going to be the pointer diff t. Okay, now let's look at this. We haven't seen this before, so let's go to Cpp reference for this one, and we'll go ahead and take a look here. Let's go ahead and just pop this in here. All right, and what is this here? Okay, so the bit width, it's not less than 17 here. So this is since C++ 11, something that's new. It tells us the type of the result of subtracting two pointers here. Okay. So what's the sort of point of this data structure? Well, this is just to tell us, or I should rather say the sort of point of having this in our iterator is to tell us how many bytes we need to jump to get to the next element here. So that's the idea. Are we going to use this right now? No, we don't need this currently, but if we add some more power to our iterators, we might need it. And the other thing that we're going to add here is a category. Okay, and what is the category? Well, again, let's go back to Cpp reference here. Well, it's this here. Okay, these are our iterator categories here. Now, again, I'm going to do this in sort of a C++ 17 way. And if there's demand, maybe we can look at the 20 way once we get through ranges and concepts. Well, we need to define a sort of tag to tell us how the iterator can be used or what power it has. And we've talked about this in the previous videos here, but basically what we're saying is, and I'm just going to pick a simple one here, forward iterator tag. Again, I don't need to use this for this particular video for what power I'm giving my iterator. But this tag basically is just a empty class type. And then we use it for things like various template constraints to see like, okay, if I can move forward, can I use this with some things like, you know, advance or something, which allows me to move forward in my data structure. Okay, so that's the idea. I'm going to define this tag here, forward iterator tag. And then we can use that later, not in this video, but again, these are the different things here. So the basic way to think of this is just like properties of our iterator. Okay, and these are just, you know, shorthand. So we don't make mistakes. Okay, just referring to the value, the pointer, or the reference. Okay, that's actually not too bad. It's not too much code here. Okay. Okay. So let's go ahead and I can clean this up just a little bit here. I'm going to make this very brief here. Okay. So now I've got, yeah, my pointer type here. I've got my constructor, and let's just keep compiling this and, you know, see what progress we make here. Okay. Okay, so I still need my begin and my end here. So let's go ahead and see here. Well, I have my iterator type now. So from begin and end, now I just need to return something here. Okay. So what can I return? Well, I need to construct an iterator here. Okay. And my constructor takes in some pointer to something here. Okay. And end's going to be the same thing. Return iterator with some data here. Okay, some pointer here. We'll just pass in null pointer for now. See if that gets rid of some of our errors here. Okay. See if we get some ideas about here. Okay, so this looks like we're getting new error messages here, but we can actually solve this problem now about where our beginning and our end is. Okay. So where is the beginning and the end? And again, let's bring up the drawing here of a data structure that looks like this. I'll give you a moment to think about it, but again, if we're at a contiguous data structure here, and perhaps let me label it here with indices, well, the beginning's just at index 0 here, and the end's just at, well, whatever our capacity is. Okay, so we can actually return our m data here. Okay, m data at 0. Okay, and you know, we could be explicit and pass in the address if we want here. And then again, that makes our end here, the m data here, will be the address of m capacity. Okay. So important point here. You might be wondering, well, if I'm returning the end here, and it's at capacity, Mike, isn't that one sort of past our data structure? Well, in a contiguous sequence, that is true here. We are actually returning, right? If I allocate this thing at capacity of, this would have 8 elements here, right? So 1, 2, let's highlight these, 2, 3, 4, 5, 6, 7, 8 here. But if I return the index of 8 here, right, I'd be out of bounds. So it's sort of one past. It's not in a contiguous structure that always makes sense. In a linked data structure like this down here, what one past means is a little bit different. But for this, we can just go ahead and say, okay, you know, return something that is definitely invalid memory, indicating that we are beyond our data structure. So observe we are one past or otherwise beyond our container. Okay, and that's how we know we've reached the end here. Okay, so that's our begin and end. Okay, so again, let's go ahead and compile this. And we're getting some new errors. That's fine. Let's go ahead and take a look at them and see what else we're missing, because we still need a little bit more power in our iterators, meaning what else are we doing with them? Okay, it's saying, okay, we're missing operator not equals, okay, because we have to know in a range-based loop here, when we've reached the end here, why? Well, let's take a look at CPP insights, right? Because this is just a for loop here, right? We need this operator not equal here. I can see it right on CPP insights here, where I'm looking for begin and end and need to compare those two. Okay, so I need an equals operator and a not equals operator. Oh, look, I need a plus plus here, right? Because we're iterating our iterator forward. So let's go ahead and see, right? I have plus plus IT I need to take care of, and maybe IT plus plus as well. We should probably just implement both of them. And let's see what else here. What else am I doing? Oh, probably dereferencing. Let's see if there's a dereference error here. There probably is somewhere. But you know, those are the powers that we need to add to our iterators here. Okay, so let's go ahead and implement those in our iterator struct here. Let's go ahead and do that here, right, within our iterator. So again, here's where I'm looking here in this structure, and under our constructor, let's go ahead and add some of these. So go ahead and pop back in here. Whoops, there we are. And let's go ahead and add some of these things. Okay. So what do I need to do here? Some of the different types to add here. Again, recalling, well, I need to be able to dereference things. Okay, so how do I do that? Let me just think about this. The first one, if I want an iterator for operator plus plus, for instance, so that'll be IT plus plus is what we want here. And for these ones, I'm just taking in my type here. And then let me go ahead and copy this here. For pre-increment, which is plus plus IT here, I'm actually returning a reference that I've modified here. Okay, this is the difference between pre-increment and post-increment. That's why I've got to just sort of think about this for a second as I'm writing this down here. For this, I can just do plus plus my pointer and then return this. Okay, return my iterator, but increment, you know, its internal data, the pointer, one address here. Okay, which effectively, again, when I'm doing plus plus on an iterator that's pointing to this location, right, the pointer arithmetic, that's just moving me to the next space, right, one integer value or whatever the type is. Okay, if you're in a graph-based data structure, you know, something that looks like this, plus plus might, you know, look different. Okay, so just keep that in mind here. But for this example, that's what we've got here. Now for this one here, for post increment here, I've actually got to create a new iterator. I'm just going to set it equal to this one, so it's going to point to the same location. Effectively do a copy constructor here. Let's do the increment on this object. Let me think about that for a second. Yep, that should be fine, because basically what we're doing with this plus plus is we're just calling this function here, and then I will return the temporary here, which is what plus plus does. That's why when folks, and I might have even mentioned on this channel, plus plus is a little bit more efficient because we don't have to do this copy. Again, this iterator is pretty small, so it's not a big deal, and the compiler might optimize these things for you. Anyways, but that's the idea. So you can use plus plus with the plus plus for your iterator, or IT plus plus pre-increment or post-increment. Okay, so those are those two operators. Okay. Let me think about what else we had. We had the operator, the urinary operator here for dereferencing here. Okay, so we don't want to modify anything. And when I'm dereferencing something, what am I doing? Okay, so let's go ahead and say I have some type here that's a pointer p or something, and then later I want to dereference it. Okay, so that's what this urinary operator is here. Now when I'm dereferencing it, remember that's always saying, hey, go into the memory and give me the actual thing here. So that's just returning Well, what's it returning here when I dereference? Well, I want the actual thing that my pointer is pointing to, okay? Which is this, my M pointer, okay? And here I am just dereferencing it, and let's go ahead and return the reference to it, okay? Let's see. So let me go ahead and write this here. Dereference, urinary operator, get back the thing we are thing, which is actual data that our iterator is pointing to. Okay, so that's what we're doing here with this one here. So for example, in our actual code here, this, okay? That's how we're actually accessing the element that's in our vector or our, in this case, fixed size array that we're implementing here, okay? Okay, so let's go ahead and let's compile this much. Let's see if I've made any mistakes here. Let's see if our error messages are still large. Let's see what we got here. Oh, it still looks like it's complaining about this operator plus plus here. It's expecting an actual the pre-increment one, since we're accessing just this thing. Let's see. Let's get rid of that type there. Okay, that's looking a little bit better here. Our error messages are changing. They are getting smaller. We still need to fix a few things, meaning we're missing not equals and equals. And we've got one other dereference operator to implement here. Or rather, I should just say the shorthand, which is operator. Let's see, operator. There we are. This guy here, which is sort of our syntactic sugar here. Now, what is this actually returning to us? Well, let's go ahead and see if I do this right here. Well, it's gonna give us a pointer to something, right? Because remember this, if I have some object and I do this thing, some type here, I use, again, this is, let me come back in here. This arrow here is dereferencing and accessing some field of a pointer type. Okay, so what's our pointer here? It's this guy here. Okay, so again, let's go ahead and return our M pointer. Okay, which we have here. And we can return a copy of it. I'm fine with that. I think that's the right thing to do. Let's see if we complain or get some different error messages. Looks like about the same amount here. Let's go ahead and pop back in here. Okay, let's go ahead and see what else we should be implementing. I think it's time to knock out those operator equals here. Now I'm going to try this here. Just as a little FYI here, for this struct here for our iterator, just so we don't get in too much trouble, because I'm thinking about this now, let's make this private here. Right? We want to mess with our state as little as possible here. Okay, but let's go ahead and write operator equals. Okay, we're just going to take in an iterator on one side here. I don't know, iterator A, iterator B, and then we want to compare them. Okay, we'll return if A's. Well, how do I know if these iterators are equal? Basically, if they just have the same pointer. Okay, if it's equal to b.m pointer. Okay, and that should be it. We need our return type here, which is going to be a bool. Okay, let's try to compile this much, see how far we get. Okay, still some errors. Something that you will see with these operators, since I made it as a function here, I can make it a friend function here. I think that might actually take care of, yes, that takes care of it. Which allows me to access all of the private members of these iterators here. Okay, I believe this also might make it a well, I don't want to make any assumptions, but that's how we can do bool. If we have equals, we don't necessarily need to define not equals. I think our compiler is smart enough that'll just assume if it's not equal, right? If this test fails, it can effectively call this function. I'm just going to put it in here. I would need to think of a good use case in this instance where they wouldn't be, opposites. I really need to think about that. But that's the idea here. Okay. Okay, let's see here. So we're almost there. It looks like we have a error message at line 40. Okay, what am I doing? I'm returning this, which is not our type here. Okay, wonder if that happened as a copy and paste. Sorry about that. Iterator here. Okay. I think that will do the trick here. Yes, because I'm returning the object and then I'm just modifying it directly and then returning it. Okay, because that's the goal. Access the object, move move its internal bookkeeping where it's pointing, and then return that iterator. Okay, let's go ahead and compile that. Wow, looks like it compiles. Okay, that's pretty cool. And let's go ahead and give it a run. Let's go ahead and see if it does anything strange. And, well, just like that, it looks like it works here. I can move this over and we can wrap this up. I know this video has gone a bit here, but I want to show you the code. But let's go ahead and show you the result here. That's super, super cool here. We've defined this custom type here, and I've been able to use it with, well, ultimately, this is how I sort of want to write my C++ using range-based for loops. But I could also use algorithms where I just passing in iterators at various positions here. I could probably even do funky stuff here, like where I get the iterator and then I do like plus plus here. Okay, so let's see if that works. Does it give us a loop here that's shorter? Let's go ahead and see here. Maybe that didn't work. Probably because it's giving us a copy. Actually, this is a good way to test here. Let's see if let's see if that one works here. The two different tests here. Aha, yeah, that one gives us a shorter, perfect algorithm loop. Okay, so at least I'm convinced that's the right behavior. The first one didn't work because, again, it was passing in begin, and then the copy that was moved forward. Here I'm just saying, hey, modify the actual beginning, move it forward here. So that's kind of cool here. Again, we can use these operators here. So anyways, what we've done again is by defining begin and end and some of these iterator things here, like be able to dereference, move our iterators forward or backwards, or actually, according to our tag, we're not able to move these backwards. But as a challenge for you, actually, as we review what we've done here, if you don't want this to be a forward iterator, if you want it to be bidirectional, right, think about what you need to actually do here, right? Change this tag. Try doing minus minus, and then see if you can actually implement minus minus in both ways that we did plus plus here. It shouldn't be too hard. Do a post increment and pre increment for you. That's a good exercise here. Okay. Okay, so anyways, brief code review of our class here, and then I think we'll maybe do a full code review and maybe change some things around. But the basic idea was to create a nested data type here, this iterator here. We use a little bit of shortcuts just to make our life easier with this using, so don't get too intimidated by this, right? This is stuff that we know if you've been watching this series here. We've got our constructor here, which is again saying, how do we construct this particular iterator? Now, this iterator is a nested class here, so the real only construction that we're doing is when we again go down into our actual the meat of our data structure here, where we have our begin and end functions, right? I could have said that beginning was 1 or something or whatever, and I could write my own functions that return me iterators somewhere else. Like I could write a middle or something if I wanted an iterator that always just took the current size and divided by 2 or something, but that's just some different things that you can do. So anyways, that was our constructor, and then again here's just all these sort of operator overloads, and this is again a feature or maybe an area where C++ does a nice job of being able to implement some of these overloads. Other languages do this by you just overload different function names, which is also fine, but this wasn't too bad here, although it can be simpler. And then we did our equals equals, not equals, which you didn't have to. And again, this was the ultimate thing within our iterator object that we are moving along. Now, I'd also give you a challenge for this particular data structure. If you're playing around to just make this an integer or something, that would totally be fine. But I want to leave that as an exercise, and maybe you could actually time it, see if there's a performance difference or some sort of change that's interesting there. All right, and then the fixed size array we've already sort of reviewed, but it's just a basic heap allocated array, and that's it. That's all there is to it for writing your own iterator. So let's go ahead and, since you folks ask sometimes, here's most the iterator on the screen. If you want to look at it in one place, leave that up for a few seconds, and scroll down here, leave that up for a few seconds in case you want to try to pop that in here. It's a great exercise to try to write these things, but that's basically it. All right, so with that said, I'm going to go ahead and wrap up this lesson. As always, you can check out or follow these lessons sequentially on my website, courses.msha.io, which just has the links to the YouTube that you can track your actual progress. And I want to do a brief shout out to all the folks who are members of this channel. If you've made it this far, and thanks for your continued support. Thank you to our subscribers. And again, let me know if you want to see other cool things with iterators. I think we'll probably look at some of the concepts and constraints a little bit to actually making use of those tags later on in the series, but let me know in the comments below if that's still interesting to you. And we will probably do another code review of this video just so there's a shorter version when you just need a quick recap or something how to write iterators from scratch. So with that said, folks, thanks as always for your time and attention, and I'll look forward to seeing you in the next one.